So it is typically the case in a machine learning problem that we start off with some data set X and its corresponding outputs Y. And there's a function f that describes the relationship between X and Y. In a medical setting, an example would be that X could be tumor size and tumor texture. And Y would be the corresponding label for the tumor. So in this case, it could be benign or malignant. And our goal with our supervised machine learning model is to be able to derive a function f estimate that approximates f so that we can describe the relationship between X and Y. So our goal is to derive function f estimate that approximates f. Now, in order to do this, in order to accomplish this goal, we must first gather some data. And to do that, we basically sample from this distribution X. So let's collect some data from X and look at the corresponding outputs from Y. And let's call this sampled data set X data and Y data. And this is essentially our training data set that we will collect. Now, this X data and Y data, let's call the relationship between these two a function f data. And let's now say that if we want to find a function f estimate that approximates f, we can simply first look for a function f estimate that approximates f data. Because f data is like a subsample of X and Y, the function that describes X and Y. And we will talk later on how this assumption may not be the best. But for now, let's just assume that we need to find a f estimate that approximates f data. And let's set some guidelines on this f estimate. Let's say that f estimate is parameterized by some parameters theta and theta naught. And to find f estimate, we can take an optimization approach. So let's find theta and theta naught such that they minimize some objective function j. And this objective function is equal to a loss term that describes how different our function f estimate is from f data. So this will be a function of f estimate and f data. And which means that this loss term is actually dependent on theta, theta naught, which describes f estimate, and our training data, X data and Y data. Because f data describes the relationship between X data and Y data. Now, if we only wanted to find a function to approximate f data, then this objective function will be enough. This will give us an f estimate that closely approximates f data. However, we must note here that f data is not necessarily the same as f. Points that are in X are not guaranteed to be explained by f data and mapped correctly to the corresponding Y output. So the key point here is that f data is not actually equal to f. So if we only have this objective function, that allows our F estimate to approximate F data, we may not do a very good job of actually achieving our goal of finding an F estimate that approximates F. So we must add a regularization term to this objective function. And this regularization term would constrain our F estimate so that it doesn't become too similar to F data, that is unable to generalize to data within X that are not in X data. So this regularization term allows our F estimate to be more similar to F and not to become too attached to approximating F data. And this term is again dependent on the parameter theta. And for different applications, this loss term and this regularization term may be different. And we will see what these are for the support vector machine in a later video. Now, balancing this loss term and this regularization term is the hyperparameter alpha. So just to reiterate, we have a hyperparameter alpha. And this alpha is unique in that it is a value that we must choose. So and in turn, it determines how much weight we place on the loss term and how much weight we place on the regularization term. And unlike theta and theta naught, alpha is not determined through the minimization of the objective function j. So how do we actually find alpha? What is the optimal alpha that we should use? In a later video, we'll go through the method of cross-validation, which is actually how we find alpha in practice using training data only. And we'll also talk about how this choice of alpha will affect the performance of our model. So stay tuned.